Okay, students, we know the formula of absolute refractive index. Okay, now we can calculate the refractive index of glass. So, see, refractive index of glass is equal to speed of light in vacuum by speed of light in glass material. So we know that speed of light in vacuum value we know 3 into 10 power 8 meter second power minus 1, and the speed of light in glass we know the value 2 into 10 power 8 meter second power minus 1. So these gets cancelled, you will get the value as 3 by 2, which is 1.5. So the refractive index of glass is 3 by 2 or 1.5. And next, refractive index of water. Refractive index of water is equal to speed of light in vacuum by speed of light in water. So speed of light in vacuum is, we know the value 3 into 10 power 8 meters per second by speed of light in water is 2.25 into 10 power 8 meters per second. Then gets cancelled, you will get its value as 3 by 2.25. So we will get its value as 300 by 225. So if we cut this, 25 12s are 300 and 25 9s are, so that is 12 by 9. Again 3 4s are and 3 3s are 4 by 3, or this value is 1.33. So the refractive index of water is 4 by 3 or 1.33. Similarly, we can calculate the refractive index of air. So, which are absolute refractive indices, and simply we call refractive index. Refractive index of air is equal to speed of light in vacuum by speed of light in air medium we have to write. So, speed of light in vacuum is, so we know that 3 into 10 power 8 meter second power minus 1 by velocity of light in air is, velocity of light in air medium is 2.99 recurring number into 10 power 8 meter second power minus 1. Then this gets cancelled, you will get the value as 3 by 2.99. If we calculate its value, we get 1.003. This is the refractive index of air. So, see my dear students, so speed of light in air is 2.99 into 10 power 8, and the speed of light in water is 2.25 into 10 power 8, and in glass is 2 into 10 power 8. See here, as air, water, glass, speed is decreasing. So speed of light is decreasing, refractive index is increases. So speed of light in glass is 2 into 10 power 8, its refractive index is 1.5. Speed of light in water is 2.25, it is more than glass. Speed of light in water is more than the speed of light in glass. So it has speed is more means its so will be less. Its refractive index will be less because we know the formula for refractive index. We know the formula of refractive index. N is equal to C by V since C is constant. Since C is constant, N is inversely proportional to, so N is inversely proportional to V. Means if the speed of light in a medium is less, if a speed of light in a medium is less, it will have the more refractive index. We have a table, we have a refractive index table in the textbook. So we have a refractive index table in the textbook. So that is, here you see, my dear students, a diamond has more refractive index, that is 2.42. So diamond has more refractive index means speed of light in diamond is less comparing to all other mediums given in the table. Okay, so refractive index is inversely proportional. Means if the speed of light in a medium is high, speed of light is more, refractive index is less, and vice versa. So, and vice versa also we can write. So, if it is more, it will be less. Okay, students, that's why you see from air to water, water to glass, speed is decreasing, refractive index increases. Refractive index is increasing. That is, you can observe in the table also. You can observe in the table also. Now, the next one, factors affecting refractive index. Factors affecting refractive index. So factors affecting refractive index. This refractive index N depends on two factors. The refractive index N depends on two factors. One is, this N depends on two factors. So one is nature of medium. So one is nature of medium. Nature of medium, and the second one is wavelength of the light. It depends on wavelength of the light. So the refractive index depends on the two factors. So one is the nature of medium and another one is the wavelength of the light. And see, refractive index of the diamond, refractive index of diamond is 2.42. If a medium has high refractive index, it is said to be optically denser medium compared to other medium. So if a medium has high refractive index, if a medium has diamond 2.42 which has a high refractive index, so means comparing to glass, refractive index of glass is just 1.5, refractive index of glass or benzene also 1.5. Refractive index of glass is 1.5. So if I compare these two mediums, it has high refractive index and this has low refractive index, then it is said to be optically denser medium. It is said to be optically denser medium, and it is said to be optically rarer medium. So this is optical density. So you can call optically denser, optically rarer. If we compare two mediums, so if that medium has a more refractive index than the first one, then the first medium is said to be optically denser and second medium is said to be optically rarer, only for these two comparisons. Optical density is different from the physical density. Optical density is different from the physical density. Physical density means mass by volume. Here optical density means it has more refractive index or high refractive index. So kerosene generally 3 or 4 or some drops of kerosene falls on the water, it floats on the water. Means the general density of kerosene is less than the density of water. That's why it is floating on the water. But optical density of kerosene is more than the density of the water. So if a medium is optically denser means it should not have more density. The example what is given in the textbook or for our clarity is kerosene generally floats on water. We know that. Means kerosene density is less than the density of water. That is the normal densities. I am speaking here the normal densities, which is the mass per unit volume, mass by volume. But in kerosene, light travels with less speed. Means kerosene has more optical density because it has more refractive index than the water. So what is the refractive index of water, my dear students? 1.33. But if we see the refractive index of the kerosene, you see, my dear students, refractive index of the kerosene is 1.44. Refractive index of the kerosene is 1.44. Means kerosene is more optically denser than the water. Means in the kerosene, light travels with less speed, the kerosene material. So, but the physical density of kerosene is less than the density of the water. So what is refractive index we have seen, and my dear students, remember the formula for refractive index. Refractive index of any medium is equal to speed of light in vacuum by velocity of light in the given medium. Which medium's refractive index we want to find? The velocity of light in that medium should be there in the denominator. C upon velocity of light in the given medium should be there. Okay students, now we are going to learn relative refractive index. So the previous concept we have seen what is absolute refractive index. Absolute refractive index of glass is 3 by 2, that is 1.5, and absolute refractive index of water is 4 by 3, that is 1.33. Now we want to see what is relative refractive index. Refractive index of one medium with respect to another medium is called relative refractive index. So let V1 and V2 be the speeds of light. V1, V2 be the speeds of light in different media. That is first and second medium. Then refractive index of second medium. Refractive index of second medium with respect to first medium is given by n2 to 1. So we read this as n2 to 1. So or refractive index of a second medium with respect to first medium is given as n2 to 1, and that we read it as n2 to 1. n2 to 1 n2 to 1 is read as n2 to 1. So then how it is defined, you see children? n2 to 1 is given by is given by, so that n2 is equal to speed of light in medium 1, speed of light in medium 1 by speed of light in medium 2. So that is, so n221 is equal to speed of light in medium 1 means v1 by speed of light in medium 2 means v2. Now divide both numerator and denominator. Divide both numerator and denominator with speed of light in vacuum, that is with c. Then we will get n221, that is equal to v1 by c and v2 by c. This v1 by c1 can be written as 1 by n1 and this can be written as 1 by n2. So that implies n221 is equal to, so we got it as 1 by n1 whole by 1 by n2. So then it will become n2 by n1. So this n2 by n1 is called n221. You are getting as n221 means you are getting as n2 by n1. This is called relative refractive index. This is called relative refractive index. This is we are calling as the relative refractive index. So the relative refractive index is defined as, relative refractive index is defined as relative refractive index is defined as n2 to 1, which is equal to refractive index of second medium by refractive index of first medium. So this is the definition of relative refractive index. Relative refractive index. Relative refractive index is defined as the n221 means refractive index of the second medium by refractive index of the first medium we will get. This is called relative refractive index. Now so we know that n2 to 1 is equal to what, my dear students? n2 to 1 is equal to n2 by n1. So which is equal to n2 to 1 is equal to n2 by n1, and it can be written as v2 by v1 also, since n is inversely proportional to v. N is inversely proportional to v. So n2 to 1 is equal to n2 by n1, which is equal to v2 by v1. So now we can write it as, so n2 to 1 means n2, okay, this is also called, sometimes n2 to 1 we write like this also, n2 to 1, that is called n2 by n1. So n is inversely proportional to v, you will get v2 by v1. So n2 by n1 is equal to v2 by v1, which is equal to frequency into wavelength, and here also frequency into wavelength. When the same light passes from first medium to second medium, same color of the light, same light traveling from one medium to another medium, then frequency into wavelength. Elastic can be written as frequency into wavelength. Frequency remains constant, so you can write it in terms of lambda 2 by lambda 1 also. Means refractive index of second by refractive index of first is v1 by v2. n2 by n1 means n2 by n1 means you will get v1 by v2. So you are getting v1 by v2. n2 by n1 means v1 by v2. v1 means f1 into lambda 1, v2 means f into lambda 2. F is a constant, so you are getting lambda 1 by lambda 2. So n2 by n1 is equal to v1 by v2, that is equal to lambda 1 by lambda 2. So you will get, this is the formula. Now I want to find refractive index of a glass with respect to water. Find refractive index of glass. Refractive index of glass with respect to water. So this is my question mark. So what is that? Refractive index of glass relative to water. It is also called what is RA indication, children? Refractive index. Refractive index of glass with respect to refractive index of glass relative to water. I want refractive index of glass relative to water. I want relative to water. I want means refractive index of glass relative to water is equal to refractive index of glass by refractive index of water. You know. So then we know the absolute refractive index of glass. We know the absolute of refractive index of glass is 3 by 2 and the absolute refractive index of water is 4 by 3. So then you will get 3 by 2 and reciprocal of this 4 by 3 will become reverse. So then you will get 3 by 4, that is 9 by 8. So refractive index of glass with respect to water we are getting 9 by 8. Similarly refractive index of water with respect to glass I want to find means refractive index of water by refractive index of glass. So the refractive index of water value we have, refractive index of water is 4 by 3 and refractive index of glass we have 3 by 2, then take the reciprocals of them, 4 by 3, it will become reverse. So 2 by 3, so then it will become 8 by 9. Like this we find the relative refractive indices. Now, why do different materials have different refractive indices? Why different materials have different refractive indices? Because speed of light is different in different mediums. So they have different refractive indices. The simple answer is why different materials have different mediums have different refractive indices means so speed of light is different in different mediums. So they have different refractive indices.